All right, so let's continue on. So now we have a rational function. Oh my gosh. So again, the first one says use the definition of the derivative. Now this is all about algebra at this case right here. So let's see here. If I want to find the derivative, f prime of x, I'm going to take the limit as h goes to 0, the definition, not the alternate form, 1 over 3 minus x plus h, minus 1 over the original function, like so, all over h. Now, I don't like complex fractions, so I'm going to multiply by what we call the LCD here. This is a big skill for us. Okay, make sure you don't do this one. Multiply both top and bottom. This becomes 3 minus x, really minus h if I just distribute, times 3 minus x. And if we multiply top and bottom by this, let's see what happens. We get the limit as h goes to 0. On bottom, we're going to get h, 3 minus x minus h, times 3 minus x. On top, if I distribute, the first term cancels. I'm left with 3 minus x minus, if I distribute here, the 3 minus x's cancel. I get 3 minus x minus h. I'm going to show a little bit of algebra here just to kind of clean things up a little bit. The bottom stays the same. But the top, take a look what happens. I get 3 minus x minus 3 plus x plus h. And again, anything that does not have an h better cancel out. And what I'm left with is just this h on top. So those cancel. So I'm left with the limit as h goes to 0 of 1 over 3 minus x minus h times 3 minus x. Let h go to 0, and we're left with 1 over pretty much 3 minus x squared right there. And that is our, there's our derivative right there. We want to find the slope at 1. So to get the slope, that's going to be f prime of 1, or 1 over 3 minus 1 squared, which is again 1/4. That's not a 2, that's a 1, which is 1/4. Again, very tedious. So there's our derivative. Now you had one like this the night before, so make sure you know how to do this one, because you might see this on a quiz, a test, your nightmares. B says use the alternate form now. Well, that's easy. So to get the slope, that is f prime of 1, the limit as x approaches 1, the function 1 over 3 minus x minus 1 over the value f of 1, which is just going to be 1 over 3 minus 1. Or 1/2, right? That's f of 1 right there. There's f of 1. All over x minus 1. Same idea, I'm going to multiply by the LCD, which in this case is just 3 minus x and 2. That's just what that becomes. 3 minus 1 is just 2 there. So I multiply both top and bottom by that. Alright, so when we do this, we're going to get the limit as x approaches 1. Now on the bottom, we're going to get this x minus 1, 3 minus x times 2. On top, what do we get? Well, if we distribute, the 3 minus x is canceled. I get 2 minus, and if I distribute here, the 2 cancels, 3 minus x. Don't cancel anything yet. Sorry about that. Messed up there. So we get the limit as x goes to 1. Now notice it's also x goes to 1. And the definition is h. People mess it up all the time. One of the things we look for here. If I simplify, this is 2 minus 3 plus x. So I'm basically left with x minus 1 over x minus 1 times 3 minus x times 2. And the x minus 1's cancel. And we get the limit as x approaches 1 of 1 over 3 minus x times 2. And if you plug in the 1, we do get 1/4 again. There's the actual slope itself. Just right there, right? They're the same. Which one do you use? It's really up to you on a test or quiz. I might specify use one or the other, but really up to you. And the last one, write the equation of a tangent. Oh my gosh, tangent line. There it is again. Remember, you need a point, right? That's the value, right? And that comes again from f of x. We talked about that yesterday. So I need f of 1, right? Couldn't look at 1. So that's 1 over 3 minus 1, which is 1/2. So our point is 1 and 1/2. Next, we need the slope. This comes from the derivative, or f prime of x. which we already found, f prime of 1, which is the slope. We already got it from up here, so it's just 1/4, right? And then we look for our tangent line itself. To get the tangent line, remember we can use our point slope. Use your point slope form. Y minus y1 equals mx minus x1. And we would get y minus 1/2 equals 1/4. That's not equal to this. That's not a minus. 1/4 x minus 1. And there's your tangent line. Or as we like to say, tang. Now how would I grade this? Getting the point, 1 point for your slope, 1 point for that. Now depending on how hard it was, this might be worth 2 points, finding the slope itself, the derivative. Alright, here's some fun ones. We're going to start talking about what we call differentiability real soon in here. And that's what I want to take a look at right now. We want to use the alternate form of the derivative to compute the slopes for the following at x equals c. So let's take a look at this first one here, the absolute value of x. So if I were to graph this one, here's at 1, that's what our graph would look like. That's what the absolute value of x minus 1 looks like. Now we're going to talk a lot about what's happening here at this x value at 1, when we start talking about differentiability tomorrow. So we want to find the derivative at this point. So we want to see what happens. So we're going to use our limit process. The limit as x approaches 1 of our rule. The absolute value of x minus 1 minus, remember the value at 1. We're going to use the alternate form, and that just becomes 0 because 1 minus 1 there, right? Over x minus 1. And what we're left with is this rule right here. The limit as x approaches 1 of the absolute value of x minus 1 over x minus 1. Now there are two ways we can solve it, but what we want to be careful with is the idea that from here we have to look at the left hand and it has to equal the right side. That the left and the right, remember, have to equal each other. So when we look at absolute value, we're really looking at two possibilities. We are looking at, on the left side, a plus or minus x minus 1 over x minus 1. And that's going to give us two different shapes. I'm going to go ahead and graph it, by the way. If I graph it, sometimes it's easier to see. Ready? If on the positive side, I'm at a value at 1 here. Here's 1. If I look at the positives, those cancel out, and I'm left with a positive 1. And the function will look this way. Now remember, it's undefined at 1 itself, because I still get 0 over 0. But if I look at the negative now, I get the exact opposite. We're at negative 1. You might remember this graph from pre-cal last year. It's that weird absolute value graph. So when I'm looking at this right here, if I look at the left-hand limit and I look at the right-hand limit, they do not exist. I'm sorry, the limit from the left is equal to negative 1, but the limit on the right is equal to a positive 1. So we can say, therefore, the derivative at 1 does not exist. And the reason for that is because, very simple, the limit as x approaches 1 from the left of our function, of our derivative, does not equal the limit as x approaches 1 from the right of our derivative. Right there. So the limits don't equal each other. You don't need to put down a y here. You just have to know it does not exist. And the reason it does not exist is basically because the limit itself does not exist in our graph. So that has no derivative. So what we say is at a corner, there's no derivatives. The derivative can't exist. And likewise with this one. If I try solving this one, if I graph this one, hopefully you remember how to graph this one here at negative 2. This is our cubic graph. Our cubic graphs, we know what they look like, right? But the squaring of it just takes the bottom and makes it positive. So that's what this graph looks like. For me, it always looks like those birds I drew from elementary school. So if I try to do the same thing, the limit as x approaches negative 2 of our function, using the alternate form, we would get x minus plus 2 to the 2/3 minus, again, if I plugged it in, f of just 0, right, f of negative 2, there's 0, over x plus 2. I'm going to do a little bit of algebra. The limit of x approaches negative 2. my function. This becomes x plus 2 to the 2/3 over x plus 2. I recognize I can subtract those. All right, just trust me on this one. 2/3 minus 1 is negative 1/3, so I get 1 over x minus 2 to the 1/3. And again, I have to make sure that the right equals the left. Very big for us right here. And so what happens, are we ready? This is our rational function. I can graph that. Ready? My vertical is at 2. This is my graph. There's my horizontal. There's my vertical. If I pick a point, it's just going to be 0, negative. It's going to go down. Now, this is an odd power, so the other side has to go up. So what can you tell me about this limit right here? The limit does not exist. So the limit does not exist. So therefore, the derivative at negative 2 does not exist, and that is because the limit, again, does not exist. So, like the corner, this is what we call a cusp. This is what's called a cusp. And in a cusp, there's, again, no derivative. The derivative won't exist. You will see these on your test. Okay? All right. Hope you guys enjoyed the videos. I will see you all later. Bye.